Hi everyone, in this video we'll solve a problem 1.4 from the book Applied Thermodynamics. 1 kg strokes. Here the statement of the problem 1.4. 1 kg of a fluid expand reversibly according to a linear law from pressure 4.2 bar to 1.4 bar. Initial and final volumes are 0.004 meter cube and 0.02 meter cube. The fluid is then cooled reversibly at a constant pressure and finally compressed reversibly according to a law PV is equal to constant back to the initial conditions of 4.2 bar and 0.04 meter cube. Calculate the work done in each process and net work of the cycle. So sketch the cycle on a PV diagram. There are 4 processes that has been performed in this statement. In the first process, the fluid is expanded by linear law from pressure 4.2 bar to pressure 1.4 bar, and then it is cooled by a constant pressure process, and then it is compressed by the PV is equal to constant such that it's come back to its initial conditions of P1 and V1. So the pressure P1 that is given 4.2 bar, pressure P2 it is 1.4 bar, volume V1 that is 0.004 meter cube, and volume V2 that is 0.02 meter cube. 3 processes has been performed on these volumes and pressures. So let me try its PV diagram. Here is the pressure, here is volume. Initially we have the pressure P1 and volume V1. The fluid is expanded linearly and reaches its volume V2. Here V2 is state point 1, this is 2. Now next process is it is cooled at a constant pressure, so it means pressure is constant. So here the pressure is P2, which is pressure drop is taken place. Then at a constant pressure cooling is taken place, such that its volume reaches to V3 and its value is unknown, we need to find it. Next, compression is taken place by the law V is equal to constant, such that it reaches back to its initial conditions. So here from 3 to 1 compression is taken place by the law PV is equal to constant. So here we can say PV is equal to constant, and this is the PV diagram of this statement. We need to find the V3 value also, because that is further used to find the network and work from 3 to 1 also. So for process 1, so it follows the process 1 to 2 by linear law, then process 2 to 3 at a constant pressures, here the pressure is constant, and then 3 to 1 it follows the law compressions, PV is equal to constant. Find the V3 value, we know that PV is equal to constant from 3 to 1. So I can say that V1 is equal to P3 V3. You know that P3 is equal to P2 because it is on the same line. So P3 is at a constant pressure, it is P2 and its value is 1.4 bar. I'm interested to find the V3 value. So V3 is equal to V1 divided by P3. What is volume V1? That is 0.004 divided by pressure P3, that is equal to P2, and it is 1.4. Just solve this calculators, you will get its value, that is 0.012 meter cube per kg. Next we need to find the work output from process 1 to 2 we get, that is our concern. So just consider the work that is obtained from process 1 to 2. So I am just writing it's on the PV diagrams only, the rest not writing here, because for easy understandings and for easy calculation, so you can easily get it. So from process 1 to process 2 we have linear expansions 1 to 2, and we get the work output. Here the pressure is P1, here the pressure is P2. So here the volume is V1, here the volume is, let's say, V2. So this is 1, 2, this is let's say A point, this is B, and this is C point. So the total work that we obtained during this linear expansion from process 1 to 2 will be equal to, from process 1 to 2, that will be equal to the sum of this rectangle area and the half of this triangle area. Okay, so the rectangle area is CB multiplied by BA. So what is CB multiplied with BA? Then plus half, we need to find this area, it is equal to the height C1 multiplied by this C2. So from this graph you will, when you find this area, rectangle area and triangle area, you will get the work output from process 1 to 2. What is CB? CB is V2 minus V1. What is CB? CB is P2 value from 0 to P2. So P2 I can write here. Then BA. BA is change in volume, that is V2 minus V1. Then plus half C1. C1, it is change in pressure, P1 minus P2. P1 minus P2. And then C2. Again C2 is change in volume, that is V2 minus V1. Now put these values in these equations to get the work out. What is P2? Into V2 minus V1, that is 0.02 minus 0.004. So after simplifications, this terms, only this terms I am solving, it will, as it is pressure will be multiplied 10 to the power 5. So only this terms is equal to 0.0224 multiplied 10 to the power 5, and when you multiply these terms, this, let's start from this end and this point, will give you the output, that is 0.0224 multiplied 10 to the power 5. After solving, you will get the final work output from process 1 to 2, and it is 480 Newton meter. I will write here the negative sign because work is done by the fluid. So this is the work that you obtained from process 1 to 2. Next you need to find the work done, that is Next, we need to find the work input from process 2 to 3. So from process 2 to 3, here just come to this graph. Pressure is constant, so I can say P2 multiplied by this change in volume. So the change in volume is V2 minus V3. V3 value is already be determined. Now just put that. What is P2? That is 1.4 multiplied into the power 5 into V2. It is 0.02 minus V3, 0.012. After solving, we will get the work. I'm writing here from 2 to 3 work input, that is 20 Newton meter. So this is the work input from process 2 to 3. Next, we need to find the work input from process 3 to 1. Compression is taken place while PV is equal to constant. So from 3 to 1. So it must be equal to P1 V1 ln V1 divided by V3. Because from 3 to 1 we are talking, that's why here will be V3. So put the value. What is P1 V1? It is 4.2 multiplied 10 to the power 5 multiply volume, that is 0.004. Then ln, what is V1? That is 0.004 divided by V3, that is 0.012. After simplifications on calculators, you will get the work input from process 1 to 3, from 3 to 1, sorry, that is 1845 Newton meter. So all the three work at each process has been determined. Next, we need to find the network. So the network is equal to work output from process 1 to 2, work input from process 2 to 3, and work input from process 3 to 1. Now enter these values in this equation. You get the network of this cycle. It is minus 4480, 1120 plus 1845. So after solving, you will get the network of the cycle, that is minus 1515 Newton meter almost. This is our final answers. I hope you understand. If you still have any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet. Thank you so much.